Welcome everyone to today's webinar on how to future-proof maintenance operations in 2020 and beyond, and looking at new EAM insights for achieving greater efficiency and control of assets. My name is Thomas Igu. I'm the head of content at Copperberg, and I'm very pleased today to be joined by Stevie Hay, Group VP at Aptean, and Johan Berglund, production engineer at Moelven. So Johan, Stevie, welcome.
Okay, thank you, Thomas. I'll go ahead and share my screen here.
Yeah, right before we get to that, Stevie, just a quick note for all participants. So the recording of the webinar will be made available for everyone early next week, so you can revisit the presentation. We're also going to close today's session with a Q&A discussion with Johan and Stevie. So if you have any questions, you can use the Q&A button on your Zoom control panel and submit them at any time, and then we will run through them live. If we run out of time, then we'll get back to you later with an answer via email. So yeah, Stevie, off to you.
Okay. Thank you, Thomas. Let me get my sharing up and running here. Begin. Okay, thank you, Thomas, and thank you for the opportunity to present today. Welcome everyone to today's webinar. I'm very excited to be here and share some of the Aptean customer insights, and hopefully everyone can find some help and some inspiration during this presentation. I'm Stephen Hay, or everyone knows me as Stevie. Group Vice President at Aptean. A portfolio of products that I manage at Aptean has a large focus on EAM products, along with MES and OEE. MES, Manufacturing Execution Systems, OEE, Overall Equipment Efficiency products. Most of my roles have been in the consulting side of Aptean. So, my first love is working with and solving problems of our customers. So I really hope that everyone on this webinar will find something useful. I've worked at Aptean for over 20 years. My background before that was in electronics manufacturing. I'm originally from Scotland, but currently I live in Chicago in the US. So it's a good morning from me today. So the whole world, not just the industry, is going through a rapid pace of change. This means that in an industry, you're facing numerous industry pressures while we're still trying to grow and outpace our competition. There's digital transformation, there's automation, there's predictive everything. Even my iPhone will tell me, how long it thinks it's going to take to get from the office to my house. So that means it's more important than ever to future-proof your business, so you can really stay relevant for the long term. But rest assured, you're not alone. Everybody's feeling these pressures. So here's some examples in this slide of some of the challenges we are hearing directly from our customers, and I'm pretty sure these will sound familiar. Unplanned downtime, right? The downtime is occurring way too frequently. The question we have to answer is why? Why is that happening? Poor visibility into trends. That's really a data issue and an information issue, and we'll touch a little bit on today on really how we can get better at that and increasing that visibility. Better ways to manage costs. Labor costs are always very important in the maintenance world, and we'll look at a way of how some of our customers have tackled that, especially around subcontractor costs. Regulations and requirements, challenging to keep up. They're always changing. At Aptean in our products, we have a strong base in food and drink and pharmaceuticals. So obviously we're more than aware with these kind of regulations, and we perform regular validation services with those customers to really help them keep on top of that as they change processes within the systems. The one in blue in the top right, it's very interesting for our presentation today. There are too many maintenance strategies, and that really is interesting. So with so many competing priorities, how do we focus on the important strategies? You know, the Copperberg team do a really great job of defining those strategies, but we can't work on them all. We need to focus, but where and how. So within this presentation, we're really going to focus on data-driven decisions, asset transparency, and IT and OT integration. First of all, we need to define where we are in our maintenance journey. You know, how's your organization maintenance strategy evolving with the times? What opportunities are there for improvement, even if you're still in break-fix mode? And who is still in that mode? If you look at this evolution of maintenance charts, going from the left, that's us in the break-fix, right? We're really just creating work orders. The machine's down, I go out and I fix it. And that's typically where everyone starts, and it can be very difficult to get out of that that first stage. And we're really just reacting to what's going on the manufacturing floor. The second step is really, we're beginning to more preventative maintenance programs, and that can be as simple as, you know, every 3 days I'm going to go and do some maintenance on the machine. I may have some operator care coming in at that step. So the operator is actually doing small maintenance tasks, even if it's some inspections, and then getting to proactive and getting really where people want to be in this best in class is that proactive. There's predictive maintenance, there's condition-based maintenance, monitoring. The machines are really helping us make those decisions. And really that's the growth path that we're all really wanting to go on. But how are other people doing? So in this PwC study, this is on predictive maintenance maturity, companies are really spread out across this range. So just to be clear what these levels mean at PwC. So level 1 is visual inspections. So we have no PDM, then we have visual inspections. Level 2 is then instrument inspections. Level 3 becomes real-time condition monitoring. And then level 4 includes alerts based on predictive techniques. And you can see that really stays pretty level over a couple of years span. But wait, let's think about that. We've only have 11% doing actual predictive techniques. What about the rest of us? And really, if you look at this chart, 70% of the study are still in manual mode. And I think it's a safe assumption that most of the companies are really in break-fix mode or very close to it. So how can we all benefit from the strategies that we talked about, and not just the top 30%? These strategies should be for everyone in the maintenance journey. So for the purposes of this presentation, what I'm going to do is define our levels on that evolution of maintenance, so we can follow that journey. So let's say level 1. So level 1 is really in that break-fix mode. We do not have OEE software, probably have older machinery, it's not linked. And when I say not linked, right, there's no signals from the PLCs or otherwise getting into software or going to the operator, but we do have EAM software. In our level 2, we're looking at demand and preventative maintenance. So it's, again, it's just that step beyond the break-fix. We have OEE software, so we are and it's probably linked to the machines. At least one machine is linked up to the OEE, and then we are using EAM software. And then level 3 is really where we're into predictive maintenance. There's several machines, pieces of equipment that are linked, are sending us the signals, and we have OEE and EAM software. So think about where you are, level 1, level 2, level 3, as we go through this, and hopefully we'll show you some techniques and some steps to move through that journey, or some practical steps that you can use today. So let's start with level 1 maintenance. So again, level 1 maintenance, that we have the machine or the piece of equipment. We have the engineer who comes and fixes that piece of equipment. and he's working with the EAM software. So either on a mobile phone, a tablet, or going back to a computer, he's the one interacting with the EAM software. And then you have the operator who is running the piece of equipment. So that is level 1. So the top 3 things we hear from buyers of EAM software are minimize equipment downtime, maximize equipment reliability, and then optimize work order completion metrics. So really, we want to start minimizing equipment downtime and maximizing the reliability. Do we know our equipment? You know, what is your asset transparency? So to be able to provide any insights, are you really tracking all of your assets inside your EAM? You know, the first step would really be take a complete inventory of your machines and get your EAM updated. And then the next step was you really need to start with periodic manual collection of operational data. So we're not talking automated data sensors, we're not talking signals from the machine, manual collection of operational data. So a great example is, you know, as a maintenance manager, your team's always messing with this group of motors, right? But you don't really know why. You just know that every day, one of your engineers, whether it's electrical, electrician, mechanical engineer, they're out looking at those motors. So this is where we need to collect simple measurements on a regular basis, such as temperature, bearings inspection, lubrication inspection. You know, again, nothing advanced like vibrational analysis. I like the KISS principle here, which is keep it simple, Stevie, and really just going out, getting those on a regular basis. And this is really where the software, whether it's an EAM or CMMS software, as it's also called, can really make this a habit. Because of course you can go take your readings, type it into a spreadsheet, enter the dates, and you're done. But really what you want to do is really alert your users, get users to put it into tablets, straight in, to really make it a habit that they know, oh, it's 12 o'clock, I need to be taking those readings. Oh, it's 4 in the afternoon, I need to go taking those readings. And then getting that data into your system so you can begin to analyze and then improve things. So how do you best utilize that data you're collecting and you have collected? How do we become data-driven? Standardized codes is probably the best first step. And using standardized codes is absolutely a best practice, because collecting that data in a standard way helps you gain the insights later. So no dirty data, right? The data really has to be clean. So it's the old garbage in, garbage out principle. For example, if you want to do some simple failure analysis, such as a bad actor report, you know, how do you know what corrective actions to take if you allow the users really to enter anything in the system? So, you know, phrases like complete a work order, tighten the belt, bearing was dry and had to grease. Get the users to select these options from drop-downs, not freeform type them in, especially if it's data that we're going to analyze in graphs such as this. You know, a great example that we've seen is, you know, one mechanic entered belt tightened. Another said belt was loose. Another said belt was loose. And another one said tighten the belt. They all mean the same thing, but they're all completely different. And being able to graph and bring them together is very, very difficult. So really getting that data standardized in drop-downs with little freeform text, it makes it easier to input the data and then easier to analyze later. But what else can we do to make this a habit for everyone? And using simple phrases and these kind of techniques to reaffirm the behavior to people, it can be really important and really effective. One of our customers in Europe had great success in system and process adoption using simple terms like no PO, no pay, no work order, no work. And this really meant that, you know, if a maintenance engineer went out to the machine, he got a call, it's down, I'm in break fix mode, I better go fix it. If he doesn't have a work order, he can't fix it. And this really embeds this behavior in everyone, but those simple phrases, those simple techniques really make it powerful for everyone to remember. So no work order, no work. The other thing is, are you running a lean team? And that's very likely in today's world. Let's say it's probably 99.9% of people are running lean teams. So how are you going to have time to analyze all this nice clean data you've gathered? Do you have the resources today to do that? And if not, ask your software supplier actually to provide BI services. And I'm not talking software here. I'm talking actual services. Let them provide some insights for you. Let them analyze the data. For example, we have an offering for any customer where we will run the data in our BI tool and provide insights to our customer. We really need to look at, hey, drill into this shift because it's always going down in this shift, and look for other people to help you there once you start collecting that nice clean data. So even at level 1, here we start to see that that integration of IT and OT. So two things we can do here. One is modernize our software. So really think about implementing an OEE software. We have a great example of an aerospace customer in the Netherlands, and less than 2 months after installing the OEE software, they saw an increase of their OEE in the 10 to 15% range. And that was even before they started to analyze the data. So just by implementing and installing the software and the internal communication about what the software tracks made a huge impact on this business. Operators really became more aware of the importance of maximizing the machine output. And I think everybody will say, yes, my whole team's invested in what we do and how we do it. But this really solidified it for this company that everybody really, oh, we're going to measure this. It's really that important. And everybody then focused on it. So even before going into real good analysis stage with the data, they'd already seen huge gains just by going through that process. And the second piece we can do is modernize equipment. So in level 1, we're saying that our machines aren't linked. We're not getting the signals that we need for OEE software for downtime analysis. So even though Aptean is a software vendor, we partner with hardware vendors to provide sensors, PLC kits that can collect data via an OPC server. Here we see a couple of different types of that monitoring hardware. Magnetic sensors that can be provided, it can be providing that additional information such as vibration analysis very quickly, plug it in, put it on the motor. A typical food and beverage requirement is counting in and then counting out. So those yellow ones that kind of look like minions, we can add those simple wireless sensors in a matter of minutes, and that can lead to valuable data capture because they're immediately sending that signal, getting the information to really do those in and out counts. So very quickly we can add these simple pieces of hardware really to help you, start growing towards that level 2 set of maintenance. Which brings us now to level 2. So level 2, if you think again, we have the equipment in the middle with the engineer coming to fix it, and he's interacting again with the EAM software. We have the operator running the equipment, but now the operator is interacting with the OEE software and getting signals and information from the OEE. So how can we be data driven? So BI, everybody still talks about BI, but it's really what we see is it's still being used for reporting. And what do I mean that? A report is just a list of static data. It's like a snapshot in time, and BI is really meant for something else. It's a tool to help make business decisions. It's information. You should be analyzing that. You have to convert your data into information, and how do you do that? Perhaps thinking of it this way: BI tools are not just for executives. It's not just for the top floor. Software packages, they come with the BI embedded at the user level even. So you know, we want to give the end users the ability to do that analysis. Give the tools to site managers, crew managers, engineers on the floor. You know, who better than those teams to identify and rectify which machines, which shifts, which crews are causing the problems. You know, make BI a company-wide wide initiative. You know, empowering the teams can really get managers managing and not turning wrenches. We had a automotive customer in North America who, as they moved to level 2 in their process, their reduction of reactive work orders went from 85% to 20%. They completed 25% more work with 75% more fewer resources. And then they reduced their consumable costs by 50%. They didn't need to have so much flying around in that break fix mode as they emerged out there. It was amazing results from this customer. The graphs actually on the screen are from a wood and lumber company here in the US, and this is these are the startup metrics. You know, initial implementations at the site, or what we call adoption metrics. And when these metrics take off, you know that people are recording time in the system, and then you know you're starting to capture good data in the database, even if it's manual at this point. You know, we reviewed this with a customer, and this is some of the feedback in our discussions they gave with us. An often heard comment from these plants that have implemented our software is the degree of organization the solution is provided to work orders. Everyone at the facility is now on the same page regarding maintenance. Employees across departments see the same information and are able to provide feedback as to the priorities based on available resources. Management is then able to make better decisions in guiding the maintenance department to those work orders deemed to have the greatest need. For larger organizations, the SaaS solutions also give corporate-wide visibility to the data, enabling comparisons and best practices sharing across the sites. This more proactive approach to maintenance activities across the locations has led to meaningful cost savings for the organization. So really, really powerful messaging from this customer. But what is this graph actually showing us? So on the left side is the adoption metrics of the facilities. So as they switch on, you see that gray chart really took off for that, I would think is the Texas facility, really started as they grew into the system over a couple of years. And what does that turn into? So if you look at the right-hand side, as the preventative maintenance work orders went up, the breakdowns went down. Now, if you remember back at the start, we talked about, you know, reliability and higher efficiency. So the less breakdowns you have, the more preventive maintenance work orders we're doing, planning, and executing, the lower the breakdown. And that's just some simple metrics, just based on, you know, breakdowns and work orders in the system. And you really see a good correlation there. But once you've identified the assets, you know, let's get the operators involved. And this is an important step in level 2 and beyond. You know, using software, using OEE software, it's really critical that the operator becomes empowered here during this step. You know, everyone knows there's downtime, right? We all have downtime. You know, whether it's changeovers, whether it, you know, really is the machine down. A recent interview with a company installing OEE software said they took 12 hours for a changeover. That was their typical changeover. Well, once they started measuring it, they found it was actually 13 hours. And when every minute counts, that's too long. You know, many machines can send signals that they've stopped, but the machine doesn't really know why, right? So it's saying, hey, I'm down, I've stopped, right? And really, you know, the outside influences, really, that's where the operator really, you know, interacting with the OEE software allows you to capture those real reasons why. They can code it and say, right, it's down because of this. And then that allows you to really get to the ability to get those real root causes, right? You may think, hey, this, you know, we're always going down because of this, and you find out it's actually not. I'm running out of materials, right? You think you're always having, you know, lots of changeovers, but it's not. It's maybe a different reason. And really capturing that information is critical to get better. You know, we have an automotive customer in Europe that, increased their production by over 50%. And this seems a fantastic number. And in fact, the number was so high, their production software gave an error. It didn't believe the increase. The ROI for them was too fast. But this is a real life case, and they talk about it all the time and what it did for them. But again, allowing them to find out what their downtime really was and the real reasons, being able to analyze it and get to root cause. So we talk about cost. Here's where two of our customers really have done a great job of marrying IT and OT here, which really, translates into huge cost savings. A manufacturing of carpet weaving machinery in Europe saved a lot of time and a lot of money just by telling one of their main on-site contractors, because we all have contractors, and this was this contractor was a team of people, to scan a work order each time they started a new task. Now remember, no work order, no work. Not only did this create more visibility, it also made monthly invoicing approval easier, and contractors were only allowed to invoice time that was actually spent on real concrete work orders. And then this shows that transparency not only applies to equipment, but to resources as well. So we have all our resources tracking in our systems as well. Steel manufacturer in the US, they utilized really in a similar way, a simple time card scanning system to capture the work times and work projects for contract labor. And then they import the data into the receipts module of the EAM to review and approve. And it's a validation of the work performed. So two slightly different ways to get to the same benefits in managing our contractor costs. So that brings us to level 3 maintenance. So what do we add on now from level 2? So of course we've got the piece of equipment, we've got EAM and OEE software, but now what we're doing is we're gathering all that information and allowing either reliability engineers or control engineers to analyze that data. Really taking that one step, trying to get to that predictive maintenance or analysis or more advanced analysis. So you have the reports, you have the charts, and the users have access to those tools. Now what? Now what do we do? Right? We want to be much more advanced. Well, what we're saying is give the data to the users. Let them play with it. Before I said give the BI to the users, now I'm actually saying give them the data. In larger organizations that have extensive systems, control engineers, production engineers, we're finding more and more companies are giving that next wave of engineers the data and let them analyze and interrogate. If you think about a dashboard, if we create a dashboard in BI, you're actually coming at it with a fixed point of view. You're saying, these are the important data elements and trends and metrics I want to measure and analyze. But there may be new things, there may be hidden things, and how do you find those other trends? We have a Japanese automotive customer based here in North America, and they're doing that very thing. They're getting all the signals, all the data through our OEE software, putting them into a database and saying, engineers, here you go. They're providing the data directly for them to analyze, go find trends, go find other things that we can improve. And how do we get that information to the operator? So I mentioned that the operators, it's very difficult to, it's very important to empower him and get the operator involved. And this is really where IT and OT really need to work together. One way is to present root cause analysis and corrective actions of previous failures directly to the operator, real time on the screen. You'll see when we see the Moelven presentation on how they want to become supplier independent and providing that data to the operator from multiple data sources. This is a great vision. Excuse me. The OEE software is really where the operator interacts with all our systems, right? That's their point of entry, and this is where we can deliver the most, right? And if you've ever been in supply chain business, they talk about this last mile of delivery, and that's really where the OEE is. It can gather all that data and present it to the users. what about COVID-19 alerts? And in this example, this is a real screenshot from one of our customers in the north of England that was presenting real-time information to the users on the floor of protocols and the new protocols, and any information presenting directly to the users on the floor. And really, when you're getting into this, level 3 in advance, where can you go, right? Where really is the ideal? And we have a North American drilling company really being data driven and pushing that integration of IT and OT. So what they're doing is they have sensors on drilling rigs, and they capture the drilling states, right? Availability, uptime, directly from the drilling rigs, and they've integrated that into the EAM, right into the database to the rig assets. So coupled with the maintenance data that we're already collecting, right, from the engineers, that allowed them to have one view which overlays maintenance events with production events. And then when you see analytics to see both sides of your operation in one view, you're really going to be able to uncover cause and effect relationships you might never have considered. And I'm not talking about artificial intelligence or machine learning here. This is just human learning on the data, just viewing the data. And another benefit of this visibility is that the data can be used to reveal real discrepancies between what maintenance sees as downtime and what operators see as downtime. So for example, if a motor failure takes 2 hours to repair and return to operation, but the operator's report records this as a 4-hour downtime event, you need to determine what the truth is. Was it 2? Was it 4? Why is it 4? We all think of 2. You go back to the example of the 13 hours to 12 hours. Every minute counts. We need to find out what's going on. The question you should analyze is, was all of the downtime related to maintenance, or was some of it related to non-maintenance issues? Did we not have the material, right? Or do we always have a break at that time? Quantifying that accurately is the key to reducing it. So what does that get us, right? What really, how do we benefit, from this? So there are many steps any organization can take to improve their maintenance organization. But this slide, what I would say is, be careful. It should not be done independently. So in this chart, what we're seeing is the effects of both IT maturity and applying best practices. So IT maturity is, implementing EAM software, OEE software, upgrading to, bigger, better packages. Doing that alone, actually, in this study, reduces profitability. Because what you're doing is you're taking your bad practices and just enforcing them. One of the worst things you can do is just say, okay, I want to do what I'm doing right now and just use software for it. Use the software to help with best practices. And if you do change your best practices alone, you can see benefits. Here in this study was up to 27% impact in profitability. But if you do both together, maturing your IT system, so implementing software along with changing business practices to be best in class, you can get up to 75% impact and profitability. And that really gets fantastic results on your business. So in summary, this one is one of my favorite quotes, and anybody who's worked with me or is part of my team has heard me say this many times: progress, not perfection. Especially when it comes to software and business practices, we just got to keep getting better, keep improving, going through this journey. And it really doesn't matter where you are in this maintenance journey. You can always find areas of improvement and goals of where you want to go. But wherever you are in your journey, good luck. So that concludes my section of today's presentation. And what I'm going to do is I'm going to hand over to Johan Berglund. Johan is operational engineer at Moelven Industrial in Sweden. Johan?
Hello. Thank you for having me here, Stevie and Copperberg team. I'm going to share my presentation right now. So now maybe you see it soon in full screen. There. Yeah, the first picture here shows that me and my team have been presenting for Aptean, or previously Optiware, which Aptean acquired quite a few times. So we are, it's almost the same procedure as last year for us right now. But it's really fun. We do great efforts together. So now today's topic: how can we future-proof maintenance operations in 2020 and be even competitive? We'll go through Moelven. We'll go through our EAM solution, API Pro, where we are, methods we apply, and where we want to be. We'll as well stumble across the digital sawmill, which was a unique Swedish government-founded project, and how we manage the data with regards to traceability and integration, and I mean, analyzing and calculating in the flow of data. Moelven is a Norwegian company located in the Norway western part of Sweden mostly. We both have sawmills and different type of added value, like painting and stuff like that, to the wood, and sell them to construction equipment, and as well as construction modules and glulam. And yeah, we are approximately 3,300 employees. So if you'd like to know more, please Google it. I'm part of the division Timber, which where we have this Moelven Digital Sawmill in Valås and Karlskoga. The region is quite famous for military industry, so you might have heard of them. With regards to Axos, we today operate 110 production places, and for API Pro, we have implemented it in 12 sites. Where do we want to be in the future? Yeah, we want to be available, and that's both regarding our production facilities, but as well the data. We want it to be AI driven. We want it to be fact based, so we can optimize efficiency and streamline the energy efficiency, so that we can maximize each log's value in any phase of the processing to our customers' maximized value as well. I mean, logs are natural material. It is unique, so we need to maximize all that value. So here in the lower part, you see the process in brief. We put the logs into a table and sort them, and put the similar logs in the similar pile. And then we debark them and we split them into pieces. We store them and we put them through the dry clean. After drying, we put them one-on-one and individually and cut the length, so that we maximize the value of each and every board. And then we deliver them to customer. This is a simple sawmill process. We of course have some additional processing afterwards, but this is, and here you see the data, the flow of the data. I mean, you have no marking on anything. The logs are cut in the forest. We split them into several pieces and then we dry clean them, and we sample a lot of data. But how can this relate to each other? You can individually look at one data stream and see trends and stuff like that, but you can't relate to the process. Which log was I processing? With regards to EAM, we had a pilot project with API Pro, so 2 sites, and then right after that we rolled it out. We tried to roll out a bunch of companies, and not too many in the same time, because if we don't support them from central in the group, it will likely not be as fortunate as it could be. So we don't do all the sites in the same phase all the time. That's a very important lessons from us, I think. We've been working with as a group. We've had bi-weekly meetings for internal meetings, for instance. It is quite easy today, as you see, as you are hearing to me now on a Zoom meeting. We use this Facebook at workplace for communication, so it's easy for any user to have any questions or see on a user video, for instance, or look at some process instructions or whatever. We've done a lot of work with regards to process mapping and instructions. The article management and the article register with all the related data, we try to get one unique Moelven number. So that has led to quite a lot of work, I would say. Very high demand on working hours with regards to spare parts. Today we are 12 plants in API Pro. We have more than 18,000 work orders, more than 180 resources, both externally and internal resources. We have more than 7,000 spare parts or articles, and we have 3,000 purchase orders above. So the shown chart here shows you how we integrated Axos and API Pro with both Google and how we think of the system. We'd like to have it standardized and integrated. We'd like to standardize on our KPIs, because if we don't standardize, it will be really hassle to develop our competency. So you could say from this flow chart that the OEE, we measure as soon as you have a slotted flow that you either produce in a specific speed. So in the saw line, for instance, you see we have up to 5 production places in Axos. So, and that is good as well with regards to operator maintenance, because the operators will get tasks for a smaller area compared to if you only had a bottleneck production place, which we started with. But then it will be quite a lot of tasks. How we've integrated the Axos and API Pro. For instance, as you can see to the left, we have production places in Axos, and we have positions and maintenance objects in API Pro. It's not a straight line, so from what you can see here is, for instance, this is the part of the sorting area. Then we integrate with one maintenance object in the entire structure. So you extract the data, you integrate the work orders, everything. So the first thing you do when you get the error message from Axos to API Pro, you start with selecting the entire correct maintenance object in your structure. But as this object here is in the structure, it's quite an easy job to select the correct object. So we didn't find any other better ways to do it, as you don't have a correlated structure with regards to downtime causes, for instance, and the maintenance objects. A machine that we have in API Pro could have different downtime causes, and it will never be one-to-one. Hence, we integrated in this way. It's easy, it's available. You have the Axos OEE operator, which is always working in Axos and codes his downtimes. You can just simply click send to maintenance system, and the work appears in API Pro. So it's an easy, available solution for us. So you don't need to log into a new system. You don't need to add an additional screen, for instance, just to make a job request. So that's a good, huge benefits for us, I believe. It's quite easy to see if you reported it, as it gets a new symbol, and you can filter on the work order here in API Pro. So this is the available information in Axos. So at least you have enough data to know, did I report it, and which order can I follow up in API Pro? The dashboard, from what we've seen, is I mean, it's a very, very nice manner of working, because you constantly get the updated screen. It's really nice. You always, for instance, here, which is marked with red here, here's your job requests. This has appeared, and if you process-wise go from job request to work order, then they disappear from that list. So it's very easy to get a screen like this when you log into the system. And what has happened? You get it right in the face. There's no escape. It could be an escape to do nothing, because then you'll have so much, but that's not really escape. That won't help you. But if you actively work with these dashboards, you will perform good, I think. The same thing with the operational and cycles and stuff like this. We integrated to one object in the structure, and hence we need to specify which data do we want for each and every object in the structure. Is the cycles, for instance, relevant if we have a compressor feeding the pneumatics of an entire saw line? I mean, is the number of logs relevant? I'm not really sure, but probably operational hours could be. So why are we presenting today? What's unique with our solution in the digital sawmill project? I mean, anyone samples data, right? Stevie told us earlier that his telephone tells him how long he'll spend going home. So everybody today samples data, right? For us, we don't have any marking, nothing. We diverge logs. That's what we do. And it's individual. Every log is individual and non-homogeneous. So if we don't have traceable divergent production data from individual process, understanding of the data and how to improve the process to make other better decisions and measure the outcome for continuous improvement, that would be really hard. If you don't know which meter can relate to which log, how can you then improve? So for us in the digital sawmill, fortunately we had production patterns, because the length of logs are individual as well. So from the timestamps of entering a machine, you could see which log is it and see the time patterns. And what we see as well is that the data you get is nice to have calibrated, and with the correct timestamp as well. Synchronized timestamps, that's really important. So the solution here, from what you could say, the system logics, following the same process shown before, we have a lot of systems, as you see here, going with data with regards to planning, with regards to OEE and EAM, with regards to SCADA systems and stuff like that, energy management, and the entire process down here. You have a lot of information. And then you have this NiFi solution, where we can extract data from any system here through the NiFi. And if we have this system here developed back in the 70s, you didn't have the data format that we want today, then we redo that in the NiFi. So all the data sent to the cloud is in the same form. So you don't have any different dates form and stuff like that. And we index them, so we know this board comes from this log, and their data are related. They are indexed. So it's very important to have it indexed to be able to make improvement. So and once you do analysis, more questions to be asked. I mean, Why is it like this? So you always end up in why. And today we actually have this data flowing. It's been a breakthrough since I presented it this last time. So now we actually have continuous indexed data flowing to the cloud. So now we can make continuous analysis for like previous shift or see live trends. So that's really nice. And when it comes to data, we have, as you saw in an earlier picture, a lot of different systems. What's in common for these are that they produce system for Moelven. They produce data for Moelven. So hence we own the data. And it's really important to put ourselves in the driver's position. And hence what we see as well is that we require this new competence which has not been available later. I mean, an operator could maybe in the future be able to open a SQL question and change some numbers and get some new answers. That's the way we see it. So we put out a new course for our company that several companies have had a lot of people educated, and this we do continuous as different plants will be involved in this system. And this we believe as well will give us the availability to go from supplier dependent use of small steps of the process to supplier independent use, one screen, data from all the systems. We can have one process view, intelligent, hopefully, so that it only shows us the data that we need to see, and have one HMI. So where are we? I mean, we've started a long journey. We can see that measurements are complicated. That should not be. It's very complicated, I would say. Calculations will, amongst others, verify measurements, we believe. Within the year, we will have some harvest of our yet planted seeds, we believe. So, and we have as well been awarded through the Royal Engineering Academy in Sweden. We were one of 3 out of 150 that in the entire Swedish industry was got an award through this Royal Engineering Academy. So that's fun, and that's approximately what I had to say.
Okay, thank you, Johannes. It's a great story, and it's great to hear that live on that data. I think I need to rethink my levels, right? Level 1, 2, 3, and somewhere Moelven, the digital sawmill, is probably level 12 or something. It's a fantastic story. Thank you for sharing.
Yes.
Yeah, great. Thank you, Johan and Steve. We will now actually move in the Q&A part of the webinar. So again, if anyone has questions, they can submit them via the Q&A button on the Zoom control panel. I already have a few questions, actually. My first one is, how do you calculate the ROI of an EAM software?
Yeah, I'll take that one, Thomas. I actually have let me bring up this screenshot. Give me 1 second. I'll bring this up. So there's several ways, and actually, if you think about it, this isn't just for implementing new. Hold on, share. This can be even through the journey. This is the improvements you can make as you go through the journey of maintenance. So productivity, overtime, production downtime are probably the 3 main ones, and that's what we talked a little bit about today. But even saving some on contractor costs, you can save contractor costs by managing that through the software, that can be huge. We had one great example recently. It was an aerospace customer who, you know, you can only make so many airplanes and you can only sell so many airplanes. So it wasn't really a productivity increase, but they had an ROI, and this was on OEE software and EAM, purely on overtime. So cutting down that overtime. And if you think through the journey of level 1, level 2, level 3, all of these items contribute as you go through that journey. So of course, when you first go into EAM, you'll get that first bump, but then you can continually improve, and you think that progress, not perfection. You can start continually get that improvement and get those benefits. So it's not just the initial install, but it's improving as you go forward.
Okay, good. And well, how easy would you say is it for new customers to install your solution?
Yeah, no, that's a great question. So, you know, the typical implementation of an EAM software, we're talking in weeks rather than months. So to get a site up and user using work orders, you can do it in 6 weeks. It's typically the bottleneck are the resources, right? Are the engineers gathering that data to align your, you know, how are you going to name your machines, your inventory? That's the difficult part. From our side, you know, we can spin up an environment ready the next day for you to start entering data. So it can be very quick to get you up and running.
And you have full SaaS?
Yes, our products are all SaaS. I think actually, if you looked at on what Johan had, while his is an on-premise, he's collecting all that data up to the cloud. So there are different ways of whether the product itself is SaaS, absolutely, but we also have ways of getting that data to the cloud and available across your network, across your industry, different sites, etc.
Yeah. Okay. Well, Johan, I have a question for you. What are your thoughts on price and availability of wireless or remote sensors?
Yeah, well, of course, I mean, you get what you pay for. It's easy like that, but still the technology goes quite fast these days, so you don't know what you will get tomorrow. But still, yeah, you need to be able to trust your data. I mean, for me, that's number one.
Yeah. And how do you measure the effectiveness of proactive maintenance?
Yeah, well, I mean, for me, I only think of, I mean, the purpose of maintenance is to keep a high technical level of your production, right? So for me, you can measure maintenance in many ways. You can have number of work orders and registered work hours and everything like that. But still, I mean, the purpose of maintenance is to keep your plant at a high technical integrity level. So the outcome of everything you do is you do it good, then you have a high technical availability. And if you don't succeed, you have a low technical availability. For me, it's as simple as that.
Yeah. And I have a question, because at the beginning of your presentation, you mentioned about, you talked about where you want to be, and you talked about data, and you mentioned about availability, but one thing you mentioned was about being AI driven. And
yeah.
What is your definition of AI driven? Because AI, it's one of those, you know, today buzzwords, which means a lot of different things to different people.
Yeah.
So how would you define Moelven being AI driven?
How do I define AI driven? Yeah, that's a good question. But I mean, we've tested a lot, and we've, for instance, we're filming our process, and we have done together with AI Rise and Research Institute of Sweden some testing so that they recognize production patterns from cameras. And then we have done some examples connecting that with the stop downtime codes in the OEE. And I mean, for me, it's you sample with the more data you've sampled, the easier it will be for you to have AI and recognize patterns.
Yeah. What I'd say to that, what I'd add to Johan, right? Because we're gathering complex data or larger amounts of data, is really using computers to get those patterns quicker. Because of course, a person could look at that data, but it may take them possibly years to go through that. So really, AI is really speeding up, getting to some patterns that, again, we still need the human interaction to understand and how we can make better use of it, but it's quicker, using computers to really get to that those trends quicker.
Yeah. Well, last question that just came in now is: do you plan to have a new version of API Pro Mobile?
In the short term, no. In the medium term, yes. We're doing a next generation, which will replace the next generation version will replace the API Pro Mobile. But if you're an API Pro customer, feel free to reach out either the support line, your account manager, and we can get on a call and with the product manager and talk through the roadmap and show where we're going with the product.
Okay, perfect. Well, gentlemen, Johan, Stevie, thanks a lot for your time today, and for everyone still with us. Again, the recording of the webinar will be made available next week, so early next week, so you can revisit the presentation. So yeah, again, thanks to both of you, and I look forward to welcome you all again to a Copperberg webinar soon.
Okay, thank you, Thomas. Thank you, everyone.
Thank you very much.
Cheers. Bye.
Bye-bye.